So the good news for everyone here of this being the talk right before lunch is if it sucks, you can just sneak out and get right in line for lunch ahead of everybody else. So hopefully the timing works out well for everybody here. And this is about probably a 40-minute talk that I had extra coffee this morning to do in 30 minutes. So if there are any questions or anything like that, I'm going to hang out afterwards right up here. So we got plenty of time for questions and everything like that. Cool. Well, thanks for joining. Wow, that is not right. Let's retry it. Otherwise, I can do this via interpretive dance, and we can see how that goes. Okay. Interpretive dance it is. Right, so, cool. My background, I started out in, let me try it. Sweet. I'll just talk to it while you're doing that. Cool. So I started out in offense. If you know ISEC Partners or NCC, don't get fooled by the suit jacket. My background is actually in popping shells, is always fun. Moved over to defense and was the first CISO at Etsy. Where that's kind of relevant here is at the time it was Etsy on the East Coast and Netflix on the West Coast that were really kind of inventing what we now call DevOps and this shift to cloud and everything along with it. And then now I left Etsy about 3 years ago, and I co-founded Signal Sciences, which makes a product that you can drop in to defend your web applications, especially if you're embracing DevOps or cloud. No one wants to hear about a vendor. I'm not going to be talking about that. I'm going to be talking about kind of the middle bit here. So this talk is kind of the talk that I wish I could have given myself on day one of being at that forefront of the shift of an organization shifting into DevOps, shifting into cloud. And it's really the lessons learned out of the move from the waterfall world that we all really come from to the DevOps and to the cloud world. And I'm going to give you the spoiler right now. This is the ending right now, which is that security really shifts from being a gatekeeper to enabling teams to be secure by default. Now, that is a super cliche statement, but it is also very true. And I'm going to kind of go into what this means. So what has changed? Change now happens orders of magnitude faster than it used to. How many folks have lived through waterfall and are like coming from waterfall? Yeah. There's a reason why we all drink. It's that. One of many in security. So the real shift here is that change is actually happening multiple orders of magnitude faster than it used to. Deployments go from a few times a year or every other year to a few times a week or a month or even a day or even an hour. You see some kind of leading shops in the space doing on the order of about 100 deploys a day to production now. Now, you're not going to see all organizations go to that, but you're going to see most organizations go from a release cycle of 3, 6, 12 months down to probably every month, every week, maybe every day. And this really changes from the security perspective. We had many kind of injection points into that process down to very few, if any at all, before code actually goes live. And the decentralized ownership of deployment, it used to be very rigid, right? We used to have development teams. They would ship code over, like kick it over the wall to QA. They would kick it over the wall to security. Maybe it'd go back to development from there, and then kind of back through the process, and then up to SysOps, and then finally on to production. This really becomes just from development straight to production. And that actually doesn't make us less secure. I'm going to go into that, but it's something I firmly believe that this shift actually makes us safer overall. But it changes the way that we do security pretty drastically. And there's kind of two sides that have to shift as part of that. There's the way that we adapt our technical controls, which is what this talk is about. And the other side is how do we adapt the security culture around that? And that's actually the slide deck that's up here under my very creatively named Zane Lackey account on SlideShare. But you can see the slides from the kind of how do you shift from a cultural perspective up there as well. If you want, actually just drop me an email. I can send you a more updated deck than's up there. But the real shift is that security is no longer this outsourced team. Security's role shifts from something where development teams or operations teams or anything like that kind of kicked a chunk of code or an infrastructure plan or anything like that over the wall to security, and security operated on an isolation, to security's fundamental job now is providing for those teams to be security self-sufficient. And this is really the existential crisis that is happening in security right now, is that we are fundamentally shifting the way that we've done it for the last 20 years, where security has functioned as this outsourced group and is now shifting to how do we empower those groups directly. And security really only becomes successful if we can bake it into the development, into the DevOps process. It's a lot like the challenge that kind of legacy IT teams were facing 5 years ago or so as people were starting to embrace cloud. Right? And you had these teams that were like, look, I want to spin up new infrastructure, request it from the IT team. They told me it's going to take 8 months before I get a new server for my new application. I'm not going to wait for that. I'm just going to put my credit card down. I'm going to spin up some instances in AWS. I'm going to do it in a few minutes. Security is kind of in that same spot where if it can't adapt to actually enable teams to move faster, it's going to get routed around. So how do the kind of legacy approaches fare if we don't change anything here? I've got a highly technical diagram of the safety train slamming into the development car. That's one of my favorite images ever. So what actually, oh man, it's totally cut off. Okay, so these are kind of the components of common SDLCs, right? These are kind of the primitives that every organization does it a bit different, but these are kind of the common primitives that we all share, right? Developer training, threat modeling, and so on and so on. The talk today is going to be about which ones do we need to adapt the most. So the ones I'm going to talk about are static analysis, dynamic scanning, visibility, feedback, and continuous feedback. The key here is that I'm not saying that these other pieces don't adapt. I'm just saying that as a function of time of a 30-minute talk, these are the only ones that we're going to get to focus on today. The other ones change. They change slightly as part of that. So static analysis and the 85 million page reports. I did a version of this talk and asked the audience, what's the record longest static analysis report anybody's ever seen? And the record that I've heard so far was 10,000 pages from when they ran. I'm curious if anyone has beaten 10,000 pages yet. There's got to be one. Yes, awesome. Yep, all right. So we've now beaten 10,000. That's good job, static analysis. So what I'm going to talk about here for each section is the first kind of slide, since we can't see the heading, is the legacy way that we've done this. Like, how is it typically done, kind of in legacy ways and really kind of done today. And then I'm going to say, how do we actually change these controls to do it more effectively as you're embracing DevOps, as you're embracing Agile. So static analysis has traditionally been a very heavyweight process, right? You run it once a week or once a month, maybe on like a build server or something like that. You have this really extensive configuration and tuning time, typically lasting, if you're lucky, months. And it starts very top down, right? We're going to turn on the static analysis tool. There's an 11,000 page report that just popped out. How do we start to tune and everything there? But the reality was that this was actually acceptable-ish in a waterfall world, because let's say you're releasing every 18 months and it takes you 16 months to tune your static analysis tool. All right, you missed one release. But that's really shifting, right? We're going from 18 months to every week or every month. That jump was very clear to me actually when I went from pen testing and security consulting. I left that on a Friday and started as CISO at Etsy on a Monday. And the last consulting project I did was for a major US healthcare, and they released literally every 18 months. And I started at Monday on Etsy, and they said, yeah, we released to production 20 times a day, so figure out security. So you watch this jump of controls shift very rapidly sometimes. But both these were, like I said, kind of acceptable-ish at the time. So how do we actually adapt this? The biggest thing is that we shift this from a top-down model to a bottoms-up model. And what I mean by that, I'm going to give you the methodology, and then I'm going to give you a couple examples of this, and then a few other examples of how we can use static analysis really cheaply and effectively to get some good additional controls in place. So the focus on how you actually do this bottoms up effectively is, rather than turning everything on, start with one or maybe two categories of vulnerabilities that you actually care the most about. So start with one or two classes, and then turn just those on. And what you want to do is focus on eliminating false positives in one particular category at first, before you kind of rinse and repeat that for other categories. once you do, you want to really focus that on how can I take this category, make it spit out issues that can be consumed directly by the development teams themselves, right? How do I do this where I'm actually going to accept some false negatives at the cost that I have no or very limited false positives, so that the development teams can consume this natively? Because what happens right now, right, the dirty secret right now is you run a static analysis report, you forward it to your development teams, and they just have an email filter that says, if an email comes from the security team and contains an attachment, just throw it in spam because it's probably 50,000 false positives. And then we feel good because, like, oh, they didn't reply, they must be fixing that. Like, nope, they're not reading that email. Rightfully so. And so the way that we think about this is, again, shift this bottoms up so that you can only forward on real issues that can be natively consumed by the development teams themselves. And you're trying to do this for a couple reasons. One of these kind of touches on the cultural side here as well, is that this has historically been an extremely heavyweight control. And so folks are development folks, DevOps folks, anyone there is very used to this being an incredibly slow process that is very error-filled. And so what you want to show is, as we're shifting to DevOps and starting to move faster and faster, security controls can actually enable that. They're not going to be the same old controls that you're used to that are going to have to be thrown out the moment that you start to move faster. Really, what you're trying to get to on that is, especially for static analysis, that can be run on every code commit, right? That can be run incredibly fast in real time with your development process. So I'll give you an example that, rather than starting with kind of the more heavyweight ones that require a ton of code analysis and kind of data flow analysis and everything there, start with the ones that are super quick and easy, right? Kind of think about it in terms of, what can I turn on that's going to have good results if it's just grep? And you can actually get some really good vulnerability coverage out of that. Like, let me cover command execution at first, right? For any technology platform, the ways in which you can do command execution, there's probably a half dozen, right? It's pretty manageable, and you can grep for almost all of them. And so I kind of sarcastically say, like, oh, grepping for system is low false positive rate, but there's actually a lot of truth behind that too, right? You can grep for probably the 5 ways of doing command execution in any given language, and it's going to be really fast, right? It can run on any code commit, and you're going to have a really low false positive rate, because even if that's not actually command execution, something weird is going on there that they're calling system on something in the first place. And again, to reiterate, the focus is not only on findings, right? You don't just do grep and then you're done. You start from this to show that this security control can actually keep up with this shift to DevOps, right? You're showing that, hey, we don't need to throw out our security controls just because we're moving faster. They can actually be adapted to provide real coverage. And then what you do is you iterate to try to go for deeper depth. So you iterate and start to go, okay, now how can I start to turn on like proper data flow analysis for this and feel really good about that coverage there? But you start by showing, here are the things that give me real issues, and here's the things that can run fast enough that they can actually enable velocity. 2 other ways in which you can actually use static analysis in kind of by turning the problem on its head and getting some really interesting coverage out of it. So the first is that not things that are necessarily issues that need to be immediately fixed, but instead kind of using it as a ways to spot red flags that should drive conversations, either with the security team or with development leads or anything like that. So a good example of that is when certain types of primitives show up in the code base. Hashing, encryption, file system operations, things like that. Things that are very rare and just by themselves indicate there's something a little more security sensitive happening here, and let's actually start a conversation around that. And I'll give you the example here is actually the way in which this normally, a problem we normally have in the way that we do static analysis when it's meant to be as a policy. So when we say, okay, we've mandated no use of MD5 or no use of SHA-1 in our code base, we want to use SHA-256 or some kind of more modern hashing approach. And so if your static analysis here just says, oh, I detected MD5, you need to replace this with SHA-256, the problem is, yes, you met the policy there, but you might have actually lost the war because it turns out that they shouldn't have been using hashing in the first place. So what you want to do is think about, okay, things like hashing, things like encryption. When this shows up in the code base, you can also treat that as kind of red flags to start a conversation and say, hey, I noticed you're using hashing in here. I'd love to chat about what you're trying to protect and how we can how we can best protect that. And I actually can't even count the number of times that that conversation has led to, oh, well, what we're actually trying to do is this. Like, oh, okay, great. Like, I'm glad you were trying to protect it. Here's a couple ways that we can actually do it differently that are going to be much more effective, or you're not going to have to store key and material, or things like that, right? You'll see this happen really often where folks are making a best effort to try to protect user data, but they're doing it in ways that can be improved upon. And so this is great. This is where you really want to drive conversation. The other is building proactive alerting around knowing when certain sensitive bits of the code base are actually changing. Every application on the planet has this. It's kind of the stuff that you write once and update never, right? It might be your encryption wrappers or your session management or your role-based access control or anything like that. So what you want to know is when those bits of the code base actually change. And again, that should drive a conversation. It's not necessarily bad. You don't necessarily want to block this. You just want to know when it's happening so it can be a driver for conversation. So the effective ways in which I've seen that actually done are, there's kind of two sides. You can either say, okay, when this changes, and this, by the way, can be as simple as, okay, for our session management file, just hash it in your CI/CD pipeline or your build pipeline. And if that hash ever changes, alert, right? Something changed that file. Or depending on how you do like pre-hook or post-hook commits or anything like that, like you can just look and say, does this bit of code ever change? If so, alert me. And that can drive a conversation. The other way that you can do it to actually enable even more velocity is you say, look, if you make a change to this file, it is going to page these 5 technical leaders across the organization. You can do it, you can commit it to prod, no problem, but it's going to page these 5 people. What that actually mitigates you against is the intern who's changing the wrong file is going to back that out extremely quickly because they don't want to page the CTO at 3 a.m. But like your senior SRE engineer who is in the middle of an outage and is like, yeah, I know it's going to page them. They're all in the room with me here. Like the site is down. It's fine. They can push through and you're not blocking on that change. Right? That's the key, is you want to think about the controls in terms of how do they actually enable velocity without hard blocking your teams. Dynamic scanning, the next section. This meme has no relation to dynamic scanning, but if you can find a meme that works for dynamic scanning, you're a better speaker than I am. I tried for way too long. So the way in which we've historically done it is we've typically done it as a method of discovering vulnerabilities, right? We've said, okay, essentially, if a scanner can find it, like before we release it, we should probably fix that issue. Occasionally you see organizations kind of misuse scanning as a substitute for pen testing. That's its own can of worms. How do we adapt it? And this is probably the quickest one, is that first the challenges are that applications have significantly changed since kind of the way that we initially built scanning, like dynamic scanning technology. And that's, applications, the way that we used to build them in kind of the early mid 2000s, they were very linear, right? You had a checkout flow that's page 1, page 2, page 3, page 4, things like that. Apps were very different. Now you see applications that are like, single page applications and a lot of client-side functionality and things like that. What I've really seen, and I want to be careful about how I say this, is that when you try to bring scanners into kind of modern applications, it's not that they're useless. You can absolutely invest the resources to go make them useful. It's that in every practical case that I've seen and that I've talked with a number of folks on, it's that really there's just too little bang for the buck in the historical way that we've used scanners. Now, however, they can actually be adapted for 2 really cheap and effective ways to actually use them. So the first is that ensuring the security policies that you put in place are actually being met. So let's say you've got a application that you've mandated, okay, we are going to do TLS for this entire application. How do you verify that control is actually in place? Well, scanners are actually a really great use of doing that. You just say continuously crawl the site, and if you ever see an HTTP link inside our domain, flag that, right? Alert on that. Incredibly cheap, incredibly effective. It can run continuously. It's great. The other is around policies like headers, like saying, oh, we're starting to roll out content security policy, or even just things like, hey, we've mandated the use of X-frame options or XSS protection or any of the kind of security policy headers. Continuously crawl the site. If you ever see that missing from a response, flag it and alert me. And the second is actually as a really cheap and effective way of kind of regression testing. Now, this should not be your main way of doing regression testing, obviously, but it's really cheap to make use of this in terms of time, right? Where you can say, hey, we had a cross-site scripting in this parameter, we fixed that in the code base, we've got unit tests for it, but hey, scanner, throw this payload in this parameter, and if it ever actually fires, alert me, right? Super cheap, super effective. you feel like, oh, that should never happen because we've got unit tests and everything. As we all know, as soon as you catch yourself saying the phrase, that should never happen, that is a great place to put a test. Security visibility. So Honest Ass Pages is one of the most sarcastic and amazing Twitter feeds I've ever seen. It just hits way too close to home. So the way in which we've had security visibility in the past is really logs, customer service reports, outages, but each source of information was really siloed, right? It went to different teams. Ops had logs, customer support had people screaming that parts of the site weren't working. Outages would page certain development teams or anything like that. How do we adapt this? The goal here is really to break down the silos between those teams, right? This is something that security does not have to go trailblaze some new approach here. What security's trying to do is actually just relearn the lessons of the last 5 or 10 years of organizations already embracing DevOps, whatever DevOps means to you, which is that just take these principles of previously siloed bits of the organization and focus on how can you bring them together. So how do we bring operational visibility and bring a security perspective to that all teams can consume? Right? It's kind of a superset of operational data, performance data, security data, reliability data, anything like that. I'll give you an example, which is that this graph, so just take HTTP 500 errors, right? Just classic kind of errors in the application. If you show this graph to different teams, you get wildly different responses in terms of what this graph actually means. If you ask your development team what this is, they're like, oh yeah, we let the intern push code to prod right then, it broke stuff, we backed it out, it's fine. If you ask the ops team, it's like, yeah, that was the 4th time this week I got paged. I don't know, the dev team broke something, it's fine. You ask the security team that, like, is that somebody actually discovering a real vulnerability because they're breaking the application along the way? And then you go ask your pen testers or your attackers and they're like, oh yeah, that was me definitely discovering vulnerabilities and breaking the app along the way. So the key to think about here is how do we start to bring this data together of security relevant data to operationally relevant data in a way that all the teams can consume, right? You should not have to be a security expert to consume any of this sort of data and this sort of visibility. And so you want to bring this sort of stuff together to be able to very clearly see, oh, we're actually seeing errors in the application at the same time somebody's attacking us. Now, your development teams, your DevOps teams, anyone can look at this sort of data and say, yeah, there is a real issue here, and I can start to react to it. Feedback. Office Space is like 18, 19 years old now. Look that up. So this is actually a vintage meme, I think, at this point. I feel good putting in slide decks again. So the way we've done feedback in the past is annual pen tests. And unfortunately, this really only answers the question, do I have bugs? And the answer is yes, right? We all have bugs. When applications, again, just like kind of like static analysis, when applications were only released annually or biannually or anything like that, it was kind of real-time enough feedback because we all typically run pen tests once a year, right? That's what you typically have budget for, or before a major release or anything. And you say, okay, well, here's a bunch of bugs in the application. I can hopefully use that to kind of triage problem areas. It's real-time enough. So how do we adapt this? We do this through the combination of pen test and bug bounties. So we lived through one of the earliest bug bounties before like HackerOne and BugCrowd and all the cool services like that, which I totally recommend using a service because they solve a ton of logistical issues for you. But we just kind of YOLO'd our bug bounty and turned it on one day. And the thing here is that bounty is not a replacement for pen test. It augments pen test. And what's great is each of them give you very different strengths and very different weaknesses. So using the two in combination actually gives you this really good coverage overall because bounty tends to give you very, in general, it can be deep, but in general, it gives you much broader but much shallower feedback. But on the plus side, it's much more real time, right? It's ongoing, so you get much more consistent feedback like that. Whereas then that allows you to take your pen tests and shift them to be much deeper, which is what you actually want out of your pen tests. Right now, when you're only doing pen tests, you're faced with the same choice that everyone's faced with, which is, do I ask my pen testers to go broad and try to give me general coverage? Do I ask them to focus on this one particular thing that I'm worried about? Now you get both, right? If you do them both in combination, you can actually get both. So I'm actually a huge fan of having both in combination. I really do not believe that one replaces the other. The thought lederhosen for modern application security. This joke went even worse in Germany, by the way, even for that silence. It was even less funny in Germany, so thank you. This is just kind of closing it out. How do we think about I talk to a different CIO or CTO or CISO a couple times a day at this point. What do I really see across modern organizations that are doing this really effectively and really like kind of headed the right direction on this? The hallmark of a modern application security program, it's the combination of that continuous visibility and that continuous feedback. And you treat that as your feedback loop to be able to continuously refine your application security program. Put another way, and kind of thinking from an attack-driven perspective, which is, again, how you see the most effective organizations thinking about it. It's, if you want to be successful against real attackers, you have to be able to know when your attackers are being successful against you. Right? At the end of the day, if you don't know that your attackers are being successful, you don't know what's actually going on. So there's kind of 3 keys to kind of modern feedback and visibility here that we really learned along the way. The first is you want the ability to detect attackers earlier and earlier in the attack chain. Right now, most of us are alerted because Brian Krebs calls us for comment on the massive data breach that just happened from our organization, and you work back from there. What you want to get back to is think about it from the attack chain perspective of initial recon, vulnerability discovery, exploitation, lateral movement, command and control, and exfiltration, and start kind of backwards and think, okay, how would I know if they were at this stage and succeeding? Okay, now how would I know if they were at this stage and succeeding? How would I know at this stage? And you think about it through the 2 sides. How would I know? How do I get that visibility? How do I get continuous feedback to test my assumptions? Because you're going to have to continuously refine your assumptions there. The second is why this is really useful is it gives you the ability to continuously test and refine your triage and response. So particularly through the lens of bug bounty, the first time, no matter how prepared you are, the first bug bounty report that comes in, or even not bug bounty, just the first externally reported security issue that comes in, it is going to be a complete fire drill across the organization, right? It's almost guaranteed it's going to come in some part of the site that's a part of the code base that no one knows who owns that anymore. And you look it up through source control and like, oh, that person left 5 years ago. Who owns that? What do we do? And it's a complete fire drill in terms of how do we triage this, and organizationally, how do we find it and respond to it. The beauty of DevOps and why I not only drink the Kool-Aid now, but stand on stage and dispense it, is that this, for the first time, allows us to actually move faster than our attackers. Think about the waterfall world, where if someone, let's take a generic vulnerability here, where let's say someone found a SQL injection on the front page of your application. Organizationally, if you're releasing every 6 months and someone finds that and you need to do an emergency response, good luck, right? It's going to be weeks at best. Everyone's going to be in a panic room during that time. You're going to try to push it through the organization faster than the organization knows how to do it, and it's going to lead to complete pandemonium. For those of us who have lived through emergency releases like that before, I see a lot of nodding in the room. It's total pandemonium on that. This is why DevOps is great, is that every development methodology has vulnerabilities in it. As you think about getting agility, whether you call that DevOps, whether you call that CI/CD, whatever you call it, this allows us to move faster than our attackers for the first time. This is why we can get to a net safer and secure, more secure place. The third and final bit is the ability to continuously test and refine your IR process, your SecOps, DFIR, whatever you want to call it. What you get to do is you get to treat sample bug reports coming in as if they were real issues. So say you get an externally reported issue, and it's like, oh, we had a command execution on this spot, or there's a business logic flaw on this spot. What you get to say is, okay, let's treat it as if this wasn't reported and we discovered it in some other way. How do we know that the attacker didn't discover other issues that they didn't report? How do we know if somebody else had actually found this 6 months previously and has actually been abusing it and exploiting it? How do we know these sort of incident response questions? And the first time you ask yourself those questions, you're going to be extremely unhappy with your answers, because almost all of your answers are going to be, hey, we don't actually know. We have no way to know, so we had no visibility into it. And that's what starts to drive the process here of saying, okay, how would we be able to answer these questions? I'm going to close out here with, I think far too many security talks are doom and gloom. So I'm going to give you, I'm going to close on a kind of happy note here of how this can actually be really effective. And just kind of a case study of where you can get you out of this and feel really good. So this was something where we actually had it. It's still up on Reddit. The attacker, the researcher, actually wrote this up. It was awesome. And what happened was we had a researcher. We didn't know they were a researcher at the time, but somebody was attacking us, and they discovered a vulnerability. And because we had done a lot of this kind of refinement and everything here and invested in visibility and everything like that, we were actually able to detect that they had discovered a vulnerability before they reported anything to us. And so we detected that, and they were refining their exploit payload, and they worked on it for a little bit, and then they went away for a couple hours, and they came back to test it again. Turns out before they wanted to report it, but they came back to test it again, and it wasn't working. And it's because we were able to detect that and ship a patch for it, a fix for it, out from underneath them before they'd reported anything to us. And so they actually wrote in, and it was a really funny interaction, because they were like, hey, so I noticed this isn't working anymore. I'm a legitimate researcher, and I was testing from my home IP, and you're not going to sue me, right? We're good here? And it was like, yeah, it's okay. We actually had a really good interaction back and forth. They were awesome. And it turns out we messaged them. We're like, yeah, actually check your Etsy account. We had sent you a message, and at the start just said, hey, we see you. If you see anything, if you find anything, here's the security reports email address. So, sorry? We did. Yeah. It was awesome. That was something I was really proud of, actually, is that was before we had the bounty program, and we went back after we launched the bounty program and retroactively awarded everybody who had done stuff there. So they were awesome. All right, final slide here. I really think the kind of high-level takeaway from this is that the way that we've approached security or application security in the past has been this mindset of how do we eliminate bugs before they go to production? That's not wrong, but that goal will never be complete, right? There's always going to be bugs. Just exclusively focusing on eliminating bugs before production, that doesn't actually keep us safe. Doesn't mean we stop doing that, but it's not the only approach here. The modern organizations I see here are really focusing on building on top of that to focus on obtaining continuous visibility, continuous feedback as a feedback loop into how they should be adapting their organization. And the most important part is using that to empower the development teams and the DevOps teams directly so that they can self-serve and they can be security self-sufficient. So you're awesome. Thank you for coming.